Welcome to the lecture on climate change. So let us see. So you already know that this particular lecture series is important for IS examination. Okay, so UPSC people should actually pay attention to this lecture because climate change is a very uh, demanding topic. Okay, for UPSC examiners, they keep asking the questions on your climate change, and in prelims every year at least one question is asked. Okay, and in mains it is a compulsory question. In UPSC mains, question on climate change is a compulsory question. But as far as prelims is concerned, sometimes they might ask some questions on climate change as well. Okay, so usually they are asking in prelims also, because after 2015 or 2016 it has become a very sensitive topic. So it is a very important topic as far as UPSC examination is concerned. Okay, so let us see. Now you already know what is causing the increase in temperature on earth. So greenhouse gases like CO2. CO2 is not the only greenhouse gas. There are many greenhouse gases along with CO2 like methane, nitrous oxide, etc. So methane, CO2, nitrous oxide, all these are what? All these are greenhouse gases. Now what is the meaning of greenhouse gases? Now you know that the earth, planet earth has an equilibrium, right? Planet earth has an equilibrium. Let me draw planet earth. Let us suppose this is your planet earth. Okay, let us suppose this is planet earth. Now planet earth is surrounded by a blanket of atmosphere, right? Planet earth is surrounded by a blanket of atmosphere. Now as the concentration of carbon dioxide, it is CO2, that is carbon dioxide, as the concentration of CO2 increases in the atmosphere, what happens? So see, there is sun which provides us energy. This is your sun. Okay, and the sun gives its rays. Okay, direct rays of sun are reaching on the earth. Okay, so rays of sun are reaching on the earth. Now what is the problem? The problem with increasing concentrations of CO2, increasing concentration of CO2 do what? See, first of all, whenever sun rays fall on the earth, they are reflected by the earth's surface. Okay, the earth's surface gets heated up. The surface gets heated up, right? Surface gets heated up. Now as the surface gets heated up, what happens? Some of the radiation is reflected back. Okay, some of the radiation is reflected back from the earth. Okay, so earth has land and ocean. So land will also do this work and ocean will also do this work. Although land will do this work very fast. Okay, so the radiation is reflected back. Now this reflected back radiation is in the form of infrared radiation. Okay, this reflected back radiation is in the form of IR rays. Okay, you have already learned the electromagnetic spectrum in lower classes. So there, what is the meaning of IR radiation? You have already learned there. You have already learned there the meaning of IR radiation. Okay, so now what happens is that when CO2 increases in the atmosphere, when CO2 or any such greenhouse gas, it increases in the atmosphere, more and more of these IR radiations, more and more of these IR radiations are trapped back. Okay, so it will go like this and it will come back. If CO2 is, lot of CO2 is present in the atmosphere, then the heat will be trapped inside. Then the heat will be trapped inside this. Okay, heat will be trapped inside this atmosphere, and the heat which must have left the atmosphere of the earth, the heat which must have left the atmosphere of the earth and should have gone into the outer space. Okay, so suppose initially 100% of rays fell on earth. Okay, suppose the rays which fell on the earth are 100%, the sun rays which fell on earth, those are 100%, suppose, and suppose 98% of the heat was being exited. Okay, it used to get exited, it used to exit the earth's atmosphere. Now increasing the concentration of CO2 or any other such greenhouse gas will lead to only 97.7% heat exiting the earth. Okay, it will lead to only 97.7% of heat exiting the earth. So 0.3% extra heat, 0.3% extra heat is there on the earth now because of increased concentration of CO2. Now why is CO2 important? Okay, CO2 is not just an okay, CO2 is good also and bad also. Okay, it is good and bad both. So let us understand why it is good. CO2 is good in terms of CO2 is good in limited quantities. Okay, in limited quantities. In limited quantities it is good. CO2 is good in limited quantities. Okay, so whatever concentration of CO2 was existing in the year 1700, let's say, in 1700, whatever concentration of CO2 was there on the earth, or 1600, whatever concentration of CO2 was there on the earth, it was sufficient. Okay, it was a must. Okay, it is a must for maintaining, must for maintaining, must for maintaining temperatures. Okay, must for maintaining temperatures. Okay, because you already know that during the day we get sunlight, during the day we get sunlight, and during the night what happens? During the night there is no sunlight. Okay, during the night there is no sunlight. As during the night there is no sunlight, so the thing which would have happened is that nights would have been, okay, nights would have been extremely cold. Okay, if CO2 was not there in the atmosphere, then nights would have been extremely cold. If there was no CO2 in the atmosphere, then nights would have been extremely cold. Okay, for example, let's say during the day 35 degrees Celsius is the temperature, and during the night 20 degrees Celsius is the temperature, suppose. Then if there is no CO2, there was no CO2, suppose, then what would have happened? 35 degrees Celsius would have been the temperature during the day, but during the night the temperature would have been minus 3 degrees Celsius. Okay, so there would have been a lot of variation. If there was no CO2, then such things would have happened, that during the day 35 degrees and during the night minus 3 degrees Celsius. If there was no CO2 at all, if there was zero CO2, if there was zero CO2 in the atmosphere, then what would have happened is that during the day it would have been very hot, and during the night it would have been, during the night it would have been very, very cold if there was no CO2. So in limited quantities CO2 is essential in order to maintain the temperature. Okay, in limited quantities CO2 is essential to maintain the temperature. Okay, but when does CO2 become an evil? When does CO2 become evil? So CO2 becomes evil when it exceeds a certain limit. Okay, so when it becomes excessive, then what happens? Then the heat is trapped excessively. Okay, when the CO2 concentration is excessive in the atmosphere, then excessive heat is trapped. Excessive heat is trapped then. Excessive heat is trapped then. Okay, so because of this what happens? Because of this global warming takes place. Okay, now you have already learned, I have already told you that suppose if you consider that suppose 100 sun rays, 100 sun rays heat falls on earth. Okay, 100 sun rays heat falls on earth, and 98 sun rays heat escapes at the atmosphere. These are just hypothetical examples, okay, but these are convenient to understand. That's why I am giving these examples. Now 98 sun rays heat escape 98 sun rays heat escape the earth into space. So they escape the earth into space. So they go into the space. 98 sun rays worth heat escape the earth's surface and they go into the space. Now CO2 increases in the atmosphere, suppose, because of burning of fossil fuel. Because of burning of fossil fuel, CO2 increases in the atmosphere. Now as CO2 is increased in the atmosphere, what happens? Only 97 sun rays heat, okay, only 97 sun rays heat will escape. Okay, only 97 sun rays heat will escape. Now one sun ray excess heat is trapped. Okay, one sun ray worth heat which is excessively trapped. Okay, one sun ray worth heat excessively trapped. So these things happen when CO2 increases. Okay. So when excessive heat is trapped, so it will cause global warming obviously, because already whatever heat CO2 was trapping, okay, whatever heat CO2 was trapping initially before the increase in the concentration, before increase in concentration of CO2 gas in the atmosphere, whatever heat CO2 was trapping, that was sufficient. But because of burning of fossil fuel, the concentration of CO2 has increased to such an extent that now it is trapping excessive heat. Which is not required. Trapping so much heat is not required, but it is trapping now because the concentration of CO2 has increased up to such an extent which is not at all required for us. Okay. So greenhouse gases, CO2, they absorb it. Infrared radiation emitted from the Earth's surface. So they trap the infrared radiation emitted from the Earth's surface. They absorb it. When atmospheric concentration of such gases increases, gases like CO2, nitrous oxide, chlorofluorocarbon, okay, when their atmospheric concentration increases, Earth warms by trapping more heat. Earth gets warmed by trapping more heat. Okay. Now fossil fuel burning leads to, after the industrial revolution of 1800, if you learn the history, if you learn world history in your world history is there in UPSC mains. Okay. World history is there in UPSC mains. Okay. History GS, world history. History GS, world history, when you learn for mains, in that industrial revolution is taught to you. Okay, so industrial revolution started in Great Britain. Industrial revolution started in Great Britain. Okay, yes, Great Britain only. Okay, England or Great Britain, whatever you call it. So industrial revolution started there. In 1800s. Now after that industrial revolution, the fossil fuel burning started. They started burning fossil fuel because, for example, if they are running an industry, so the machine will run on coal, suppose. Okay, so coal based machines for textile manufacturing, suppose. Okay, coal based machines for textile manufacturing. So those coal based machines will emit CO2 because coal is burnt in order to run the machine. Okay, so CO2 will be released in this process because coal is being burnt, and when coal is burnt, carbon reacts with oxygen and gives CO2. Okay, so from the 1800s, a lot of CO2 is being released into the atmosphere. From the early 1800s, a lot of CO2 is being released into the atmosphere. Okay, so that is the result of burning of fossil fuel. And after 1970s, what happened? After 1970s, vehicles increased. Vehicles increased a lot. So because of that, what happened? A lot of CO2 was released into the atmosphere after 1970s. And as a lot of CO2 was released into the atmosphere after 1970s, the global warming pace increased many folds. After 1970s because the advent of automobiles took place after 1970s. Okay, after 1970s, a lot of people started purchasing automobiles like motorcycles, cars, etc. So after 1970s, all these things increased. Automobiles increased. So again the fossil fuel burning increased because petrol and diesel are what? Fossil fuels, right? So when they are burnt, CO2 is released into the atmosphere. And this from early 1800s, if we consider 1790s CO2 concentration, okay, 1790s CO2 concentration to 2020s CO2 concentration, then you will realize that it has increased 1.4 times. The concentration of CO2 in the atmosphere has increased 1.4 times, which is 40% increase. 40% increase. Okay, so CO2. So suppose initially there were 10,000 molecules of air. Okay, 10,000 molecules of air were there, and suppose initially 40 molecules were of CO2. Okay, out of the 10,000 molecules of air, suppose 40 molecules were CO2. Okay, in 1790s, suppose. Okay, in 1790s. So in 2020, what happened? In 2020, because of daily emission of CO2 into the atmosphere, the concentration increased by 1.4 times. So 56 molecules of CO2 are there now. Instead of 40, there are now 56 molecules of CO2. Okay, so that's what is the meaning of CO2 concentration increased by 40%. That's what is the meaning of 40% means 1.4 times. Increase by 40% means 1.4 times. Okay, so 56 molecules of CO2 are there now per 10,000 molecules of air instead of 40 molecules of CO2 per 10,000 molecules of air. Okay, so 16 additional molecules of CO2 are there now in the atmosphere. Okay, these are what? These are additional 16 additional molecules. Okay, so that's the meaning of this statement. Okay, the fossil fuel burning after industrial revolution, CO2 concentration increased by greater than 40%. Okay, and half of this increase, that is 20% increase, was since 1970. Okay, 20% increase has taken place since 1970. Okay, so from 1800 to 1969, the increase was 20%, but from 1970 up to now, it has again increased 20%. Okay, so that is the meaning. Half increase has occurred since 1970s. Okay, so the rate of increase is also increasing. The rate of increase of CO2 is also increasing. Okay, now in the 1900, surface average temperature, if we compare today's temperatures to 1900's temperature, if we compare today's temperature to the temperature in 1900, okay, temperature in 1900 was 1 degree lower as compared to today. Today's surface average temperature have increased by more than 1 degree Celsius. Okay, so you must have heard that this year's winter, okay, 2023 winter was the mildest winter in last 200 years. Okay, 2023 winter, okay, this was the warmest winter in 200 years. You must have heard all these things. So this is the result of global warming and climate change. Okay, global warming and climate change. So warming of ocean, what happens due to increase in CO2? The global temperatures rise. Then what happens after the rise of global temperatures? After the global temperatures rise, actually the oceans get warmed. Okay, warming of oceans take place. Now you already know that with increase in temperature, everything expands. Okay, with increase in temperature, what happens with increase in temperature? You have already learned in lower classes. Most things expand. Because of increase in temperature, most things expand. So with increase in temperature, the ocean also expands. Okay, water in ocean expands. Due to what? Due to climate change and global warming. Due to climate change and global warming, the water in ocean expands. Okay, so the sea levels rise. Because of this, what happens? Sea level rise. Okay, so furthermore, what is the further? Now already because of expansion of ocean, sea level rise already. Because of expansion of ocean, sea level rise. Okay, so increase in sea level takes place because of expansion. Now further global warming. Okay, further global warming. Melts the glaciers. So after the glaciers are melted, what happens? More amount of water in ocean. So rapid sea level rise. So So sea level doesn't only rise because of increase in temperature, okay? Because of increase in temperature, expansion of water takes place because of that sea level rise, but that's not the only reason. One more reason is there, okay? Glaciers melt after the global warming. After the global warming, glaciers melt, and more amount of water, when glaciers melt, more amount of water is released in the ocean. When glaciers melt, more amount of water is released in the ocean. So it leads to rapid sea level rise, okay? That's the meaning. So that's why Arctic and Antarctic sea level, sea ice is decreasing. Okay, Arctic and Antarctic sea cover, ice cover. Okay, ice cover is decreasing day by day. Ice cover in the Arctic and Antarctic region is decreasing day by day. Arctic and Antarctic ice cover is decreasing, and as Antarctic and Arctic ice cover is decreasing, it is releasing more and more water into the ocean. As the ice cover is decreasing in the poles, so amount of water is increasing in the ocean, because after the ice melts, the water will go in the ocean only. So the sea level rise is seen because of melting of glaciers. Okay. Increasing frequency and intensity of heat waves. It leads to increasing frequency and intensity of heat waves. Now what does it mean? Suppose before climate change, suppose heat waves, okay, came every 100 years. Okay, so heat waves used to come even before climate change. Okay, even before climate change, heat waves used to come. But suppose they came every 100 years. Suppose heat waves came every 100 years. Suppose before climate change. So what will happen after climate change? After climate change, what will happen? Heat wave will come every 10 years. Okay, so this is called as increase in frequency of heat waves. This is what? This is increase in frequency. Okay, this is increase in frequency of heat wave. That before climate change, every 100 years there was heat wave, and after climate change now heat wave is coming every 10 years. So this is what? This is increase in frequency of heat waves. This is increase in frequency of heat wave. Means heat waves are becoming frequent. They used to come every 100 years. Now they are coming every 10 years. Okay, so the frequency of heat waves has increased. Okay, instead of coming every 100 years, it is now coming every 10 years. So after climate change, heat waves are coming every 10 years instead of coming every 100 years, which used to be the case before climate change. Okay, so these are the things. This is what is meant by frequency of increase in frequency of heat waves. Now what is the meaning of increase in frequency? Increase in frequency is done. Increase in intensity. Increase in intensity of heat wave. Increase in intensity of heat wave. What does it mean by increase in intensity of heat wave? So let us understand. Suppose 50 degrees Celsius, okay, was the maximum temperature in Libya. Was the maximum temperature in Libya. Maximum temperature in Libya before climate change. Okay, before climate change and during heat waves. Okay, so the heat waves before the climate change. Okay, heat waves before the climate change, during those days when heat waves occurred before climate change. Okay, before climate change, whenever heat waves occurred, suppose the temperature was going 50 degrees Celsius in Libya. So now the temperature will go 55 degrees Celsius. Okay, after climate change. After climate change in heat waves, the temperature is now going 55 degrees Celsius instead of 50 degrees Celsius. So this is what is meant by increase in intensity of heat wave. Okay, so increase in frequency of heat waves, you already learned here, increase in frequency of heat waves, and this is what? Increase in intensity of heat waves. Okay, this is the meaning of increase in intensity of heat waves. So increase in frequency and intensity of heat waves. And much of this global warming has taken place in last 50 years. Okay, although we say that the global warming is happening from 150 years. Global warming is happening since 150 years, but a lot of the warming, 80% of the warming has taken place in last 50 years. Okay, in last 50 years, rapid industrialization and rapid urbanization has taken place. in last 50 years. Rapid industrialization and rapid urbanization has taken place in last 50 years. So much of the warming has taken place in last 50 years. Much of the global warming has taken place in last 50 years. Okay, instead of although means lot of it has taken place in last 50 years, although the process was going on since 150 years. Okay, since the beginning of industrial revolution, in 1800s, this process was already going on. Okay, this process was already going on, but the process took acceleration. Okay, the process accelerated in last 50 years. Last 50 years means 1970s. The process accelerated from 1970s onwards, because 1970s was the era. 1970s was the era when people started purchasing automobiles. Okay, people started purchasing automobiles in the 1970s. So a lot of petrol and diesel burning started in the 1970s. Okay, so that's why much of the global warming has taken place in last 50 years, because automobile exhausts. Okay, automobile exhausts are the biggest contributor. Okay, automobile exhaust, biggest contributor to climate change and global warming. Biggest contributor to climate change and global warming. So automobile exhausts are the biggest contributor to climate change and global warming. Okay. Poleward shift of temperature sensitive species. Now what does it mean? Okay, climate change has led to poleward shift of temperature sensitive species. Let's understand the meaning of this particular statement. Okay, now you already know that this is what? This is your equator. This is your equator. Okay, now suppose a certain species of fish was found in this region. Okay, and this region is suppose Antarctica region. Okay, Antarctica region, and this particular fish can only survive at 2 degrees Celsius. This particular fish can only survive at 2 degrees Celsius. Okay, so this particular fish is able to survive at 2 degrees Celsius only. Now the global warming has taken place. Now. So instead of being found here, okay, as the global warming has taken place, so instead of 2 degrees Celsius, the temperature at this particular place has risen to 3 degrees Celsius suppose. So what will the fish do? The fish will move to the polar side. So the fish will be found here now. The fish will be instead found here now. Okay, because it wants to maintain the 2 degrees Celsius temperature, because it can only survive in 2 degrees Celsius temperature. So it will go towards the pole. Okay, so it is moving poleward. This is what? This is poleward shift. Okay, this is poleward shift of the fishes, because initially at the place where 2 degrees Celsius temperature used to be there, because of global warming, the temperature now is 3 degrees Celsius there. So what will the fish do? The fish will move towards the pole in order to find a place where 2 degrees Celsius is maintained. Okay, so when it was 2 degrees Celsius here, in those days before the global warming, when it used to be 2 degrees Celsius here, during those days, over here it was 1 degree Celsius. Okay, before warming, before climate change. Okay, before climate change. So it was 1 degree Celsius here, but after climate change, from 1 degree Celsius it has become 2 degrees Celsius, this particular region, and this particular region from 2 degrees Celsius it has become 3 degrees Celsius. So the fish will move towards the pole. Okay, because it can only survive in 2 degrees Celsius. It wants to maintain the temperature. So near the pole, it will get 2 degrees Celsius now only near the pole. So it will further shift towards the pole. So that's what is the meaning, okay, of poleward shift. So poleward shift of temperature sensitive species. Some of the species are many of the species in the ocean are temperature sensitive. You must have learned in environment and ecology that many of the species in the ocean are actually temperature sensitive. So they shift towards the pole. So poleward shift takes place. Poleward shift of temperature sensitive species takes place. Okay. Now you can have a look over here. This is from the data of NASA. Okay, this is the annual global surface temperature. It is recorded by NASA. And suppose from 1961 to 1990 average, 1961 to 1990 average is shown by this particular dotted line. Okay, 1961 to 1990 average surface temperature is shown by this dotted line. Okay, so this particular dotted line shows the 1961 to 1990 global average temperature. Now you can have a look in 1850s as compared to 1961 1990 average global temperature. Average means you are taking a mean. Okay, average means you are taking a mean of the annual temperatures from 1961 to 1990, 30 years period. Okay, so you are taking a mean. So this is the mean, suppose. So this will be a straight line because it will be a constant from 1961 to 1990. We have taken it. So this is the straight line which is for comparison. So in 1850s the temperature was much lower than this. Then it is slowly increasing. Then in this particular region, particular year, there must have been some heat wave. In this particular year, there must have been some heat wave. So because of heat wave, the temperature went a little bit above this. Okay, but then again it fell. Then over here it must be cold wave because it is much lower than this. So it fell down over here. But you must observe the region after this. You must observe the region after 1970s. Okay, so this particular region you must observe. So you can see how much it has increased, and from the 1990s onwards, it is just increasing day by day. It is just increasing day by day. Okay, so if you consider after 2010, not even a single time. Okay, after 2010, not even a single time the temperature have gone below this dotted line. After 2010, not even a single time the temperatures have gone below this dotted line. Okay, global annual temperatures, those have never gone down below this dotted line of 1961 to 1990 average. Below this dotted line, the temperatures after 2010 have never gone below this line. Means such a graph has never taken place. Such a graph was never made after 2010. Okay, the graph didn't come down like this. Never after 2010. This is the biggest proof of global warming. Okay, this is the biggest proof of global warming. That after 2010, not even a single curve has come below this dotted line. Not even a single curve has gone below this dotted line like this. I mean, a graph of this kind has never been made. After 2010, the graph didn't become like this. It never came below this dotted line. It is going up and up only. It is going rapidly up and up. Okay, so that's the meaning. Now CO2 is already present in the atmosphere. So why are the emissions from human activity significant then? Actually, human activities disturb the natural carbon cycle. You must have learned the carbon cycle in environmental ecology. Okay, what is carbon cycle, by the way? What is carbon cycle? You must have learned in environmental ecology. See, we have a tree. Then animal eats this tree. Okay, animal eats this tree. Okay, so tree has what? Tree has carbon, lot of carbon. Tree is an organic matter. So it has carbon. Tree has carbon. Now animal eats this tree. Animal is eating this particular tree. So what happens? The carbon goes into this animal. Then the animal dies. Animal dies after this. So it is buried in the ground. Okay, it gets buried in ground. After it gets buried in the ground, after reaching a certain depth, because of the heat of the earth, it gets converted to fossils. Okay, then because of volcano emerging from the surface of earth, the volcano will release this particular fossil carbon from these fossils is released in the form of CO2 from earth's volcanoes. Okay, then that CO2 will go again into the tree, because tree will take that CO2 for photosynthesis. Okay, then again animal will eat. So this cycle continues. Okay, but what humans have done? Humans have cut down trees. So CO2 being taken down by the trees for photosynthesis, that has reduced. Moreover, we are extracting fossil fuels. So we are exhausting CO2 in the form of automobile exhaust a lot into the atmosphere. So already trees have gone. So those who are absorbing CO2, those have gone. So again CO2 increased. Okay, and we are extracting fossil fuels and we are burning them. So again CO2 increased. Okay, so we have disturbed this delicate carbon cycle. Human activities have disturbed this delicate carbon cycle. Okay, human activities have disturbed this delicate natural carbon cycle. Extracting buried fossil fuels and burning for energy, CO2 is released. Okay, and on the top of that we are doing deforestation. Okay, so what is happening because of that? Because of deforestation we are actually reducing the number of trees. As number of trees are reduced, so the people taking CO2 for photosynthesis, okay, the organisms taking CO2 for photosynthesis, those are trees only. Trees are the only organisms which take CO2 from the atmosphere and release oxygen. Okay, so trees are the only species on the earth that take CO2 and exhale oxygen. So that process is also gone, because CO2 being taken for photosynthesis will reduce. As the number of trees are reduced from, suppose 100 trees are reduced to 10, suppose, what will happen? 100 trees were consuming CO2, 100 trees were consuming CO2 for photosynthesis. Now only 10 trees will consume CO2 for photosynthesis. So the concentration of CO2 will increase. Moreover, we are extracting fossil fuels. We are extracting fossil fuels from inside the earth, and we are burning them. We are extracting fossil fuels from inside the earth and we are burning them. So what happens? Again CO2 increased. Okay, so these are the things which have increased the concentration of CO2 in the atmosphere. Okay, now because of global warming, troposphere is warming, but stratosphere, where ozone is present, is cooling due to decline in ozone. So what is happening? The thing is that you have already learned the various layers of atmosphere. You have already learned the various layers of atmosphere in your geography GS. In geography GS, you have already learned the various layers of the atmosphere. Troposphere is the lowermost layer of atmosphere. Okay, we are standing on the ground. When we are standing on the ground, what does it mean? We are standing in troposphere, because troposphere is the thing which we are surrounded by. We are surrounded by troposphere, right? Troposphere is the lowermost layer of the atmosphere. Now troposphere is warming because of increasing CO2. Okay, troposphere is warming because of increase in CO2 on the ground. Okay, so because of this, troposphere is warming, but stratosphere is cooling down because of decline of ozone. Now CFC, chlorofluorocarbon. CFC means, what does it mean by CFC? CFC means chlorofluorocarbon. Now it leads to decline of ozone. Okay, it leads to ozone hole. CFC lead to ozone hole, and because of ozone hole, what happens? Because of ozone hole, the ozone is not trapping heat. Ozone hole leads to decline in ozone in the stratosphere. Okay, in the stratosphere, ozone is decreased. So now the ultraviolet rays of the sun, the UV rays of the sun, are not filtered properly. UV rays of the sun are not filtered properly. Okay, as UV rays of the sun are not filtered properly, they are reaching the surface of the earth now. Okay, so let me give you an interesting fact, that tropospheric ozone, okay, tropospheric ozone is a pollutant. Okay, but stratospheric ozone, it is a pollutant and it is poisonous also. Tropospheric ozone, okay, it is a pollutant and it is poisonous also, but stratospheric ozone is a must for life on earth. Okay, stratosphere is much above the surface of the earth. So at that particular layer, at that particular stratospheric layer, ozone is a must for life on the earth. But tropospheric ozone is a pollutant, it is poisonous. Okay, so human activities have led to increase in tropospheric ozone. And a decline in stratospheric ozone. Okay, because of human activities. So this is becoming a curse for the earth day by day. Okay, so we will look at a short note on each of the human emitted greenhouse gas. Let us look at a short note on each of the human emitted greenhouse gas. Carbon dioxide. What is the source? Combustion of fossil fuel, cement production, deforestation. These are the sources of carbon dioxide. Okay, now what are the sources of methane? livestock. What does it mean by livestock? Livestock means cow rearing, pig rearing, okay, cow rearing, pig rearing, goat rearing, okay, chicken rearing. Those are what? Those are raising livestock, okay. Then growing paddy rice, okay. Dumping garbage in open. Dumping garbage in open also leads to emission of methane. Dumping garbage in the open also leads to emission of methane, because whenever something is decomposed, it leads to emission of methane. Whenever some organic matter decomposes, methane is released, okay. So if you dump garbage in the open, the decomposition of organic matter takes place in the open. So because of that, methane is released, okay. Now using natural gas, you already know, okay. Natural gas is CH4. So in natural gas, what happens? You are burning CH4 in order to drive the vehicle. Okay. Or in order to cook in gobar gas in the rural India. In rural India, we have gobar gas. Okay. So in rural India, we have gobar gas, right? So it uses CH4 as the fuel. Gobar gas uses CH4 as the fuel. So CH4 is burnt in the oxygen. CH4, that is methane, is burnt in the oxygen, and again CO2 is released in this process. Okay. Again CO2 is released in this particular process. Okay. So this is the thing. Now what about nitrous oxides? So these are from the nitrogen based fertilizers and industries. So nitrous oxide is released from there. Okay, nitrogen based fertilizers you already know. Now what are halocarbons? These are also greenhouse. Chlorofluorocarbons, CFCs, like CCl2F2, these are what? Halocarbons. These are also greenhouse gases. Okay, nitrous oxide is also greenhouse gas, methane is also greenhouse gas, and carbon dioxide is also greenhouse gas. Okay. Now these halocarbons are also found in refrigerants. Fire retardants. Okay, they are greenhouse along with ozone layer damage. Now CO2 does not damage the ozone layer. Methane does not damage ozone layer. Okay, they are greenhouse, but they do not damage the ozone layer. So CO2 does not damage ozone layer, but it is greenhouse. CH4 does not damage ozone layer, but it is greenhouse. Okay. Similarly, now this damages ozone layer. Okay, this damages ozone layer, and along with that it is also greenhouse. This damages ozone layer, along with that it is also greenhouse. Okay. So halocarbons are refrigerants. It is used in refrigerants, fire retardants. Okay. So these CFCs, chlorofluorocarbons, are halocarbons. Those are released from refrigerants and fire retardants, and they are greenhouse along with lower ozone layer depletion. Okay. So CO2 does not deplete the ozone layer, but it is greenhouse. CH4 does not deplete the ozone layer, but it is greenhouse. Okay. N2O damages the greenhouse. It is also greenhouse and also damages ozone layer. Halocarbons also damage greenhouse, also damage ozone layer, also greenhouse gas. Halocarbons are what? They also damage ozone layer and are also greenhouse. Okay. So if the world is warming, so someone might ask, if the world is really warming, why are some winters and summers still very cold? Okay. So you must have heard about the winters. Okay. So for example, in Maharashtra, my hometown, Maharashtra state, the winter was very cold in, I think, 2018. In 2018, the winter was very cold in Maharashtra. Okay, in 2017-18. So does that mean that global warming is not taking place? Does that mean that global warming has not taken place? It is just a myth. Does that mean so? No, it does not mean so. Okay, if the world is warming, why are some winters and summers still very cold? Let us understand this. Suppose in 2018, the temperature at a certain place drops to -3 degrees Celsius. Okay. So suppose in 2018, at a certain place, okay, in Maharashtra the temperature never goes to -3 degree. I am just taking one random example. In Maharashtra, temperature never goes minus. Okay. Even temperature does not even go 1-2 degree in Maharashtra. Okay. So, but I am talking about some random place. So suppose in 2018, what happens? The temperature at a certain place drops to -3 degrees Celsius. Okay. And this is suppose the lowest in last 100 years. Okay, temperature drops to -3 degrees Celsius, and suppose this is the lowest in last 100 years. Lowest temperature in last 100 years. Temperature drops to -3 degrees Celsius, which is the lowest in last 100 years. In 2018, suppose this is the situation at a certain place. Okay. that doesn't mean climate change has stopped. Okay, this particular fact that in 2018 winter, the temperature at my place was -3 degrees Celsius, that doesn't mean climate change has stopped. Okay, scientists are able to determine with the help of simulations. Okay, so they have simulations. Scientists have simulations. Okay, that if the concentration of greenhouse gases would have been equal to that in 1700, the concentration of CO2, whatever the concentration of CO2 was there in 1700, if the same concentration of CO2 would have been there in 2018, if the same concentration of CO2 would have been there in 2018, okay, whatever concentration of CO2 was there in the atmosphere in the year 1700, if the same concentration of CO2 would have been there in 2018 and no excessive CO2 would have been released, suppose the same concentration of CO2 which was there in 1700, the same is now in 2018, suppose such would have been the situation. Then scientists have such simulations. Okay, simulations mean, what does it mean by simulations? Simulation means animation, scientific animation. That is the meaning of simulation. Simulations means scientific animations with the help of computer software. Scientific animations with the help of computer software are called as simulations. Okay, so if the concentration of greenhouse gases would have been equal to 1700 in 2018 also, okay, and in 2018 100-year record was broken. -3 was the temperature in 2018 winter. But scientists are able to tell that if the CO2 concentration would have been equal to 1700, then the record would have been -5 degrees Celsius. Then the record low would have been -5 degrees, means in 2018 the temperature would have been -5 degrees Celsius. Okay, instead of -3 degrees Celsius, if the concentration of CO2 was equal to 1700, then instead of -3 degrees Celsius, the temperature would have been -5 degrees Celsius. Okay, so these things scientists are able to tell with the help of simulations. Okay, computer simulations are computer softwares. Okay, so if a particular winter is very cold, that doesn't mean, okay, what is the meaning of this? If a particular winter is very cold, okay, that doesn't mean that no global warming is there. If a particular winter is very cold, then that doesn't mean that no global warming is there. Okay, so you must be careful of these facts. Okay, so thank you very much. Hopefully you have got this, and we will learn about climate change mitigation. Okay, we will learn about climate change mitigation in the upcoming class. Climate change mitigation, about this we will learn in the next class. Okay, side by side our nuclear and particle physics playlist, which is already going on for UPSC physics optional, the nuclear and particle physics playlist which is already going on, that will keep going. But along with that, climate change mitigation will also be taught in the next class. So thank you very much.